2, 1.
Okay, here we go. Calculus derivatives, one of the most important parts of calculus. Derivatives find the rate of change of a function. It's also known as the slope of the function. So the slope is the rate of change, is the derivative. Those three things are synonymous. All right? Slope equals rate of change equals derivative. Let's look at notation for a moment. So they've made this graph, f of x equals x squared, normal parabola like you're used to looking at. Okay, and they've talked about g of x is the derivative of x with respect to of f of x with respect to x. So d dx is one way to say derivative. F prime of x would be another way to say derivative. Dy dx would be another way to say derivative. We'll get to those eventually, but for right now, here's the notation. D over dx of f of x means the derivative of f of x with respect to x. Okay. Now we have this point, a comma of f of a, and we've got a slider with it. We can see this point move. Okay, so now here we go. Tangent slopes. So the slope of the tangent line through the point as it stands right now would be uphill from left to right. It would be positive. If I brought the slope over here, the slope of this line would be negative. It would be downhill from left to right. And if I brought it here, the slope of this would be 0. It would have a y change of nothing and an x change of whatever we wanted to. Okay, so let's go ahead and turn that on. You get this equation right here using what's called point slope form. Y minus the y equals slope times x minus the x. The slope is g of a, the x minus the x is the x minus a, and the y minus the y would be y minus f of a over here, but they already added as a positive to the other side with a little bit of algebra. So I'm going to go ahead and turn this on. And we can see that this guy does have a tangent slope line, not a secant slope line, but a tangent slope line. Okay, and with this tangent slope, we notice that anywhere to the left of the y-axis, the tangent slope of x squared is negative. It goes downhill from left to right. As we get closer and closer to 0, or the y-axis, the tangent line at 0 flattens out and the slope is 0. And as we go past, it starts off gradual, but it gets steeper and steeper and steeper. These are positive slopes as we go to the right. So this tangent slope is negative on the x values are negative. The tangent slope is positive for the x values that are positive. Okay, let's now take a look and see what happens when we want to take a look at g of x for a minute. I'm going to pick out a couple specific points. I'm going to go here at a is equal to 1, an x value of 1. Please let's read the slope. I'm going to turn off of f of x. Can we read the slope of this particular line at this point? The answer is yes, we can. Regardless of the fact that these are quarters. If we look, we go down 2 over 1. So a y change of 2 and an x change of 1 means this slope has a positive 2 at that value. All right, let's take a look at g of x, which is a graph of the derivative. So again, at x equals 1, what is the y value? It's positive 2, exactly what we were looking for. We talked before. I'm going to turn this back on for a moment. We talked before that the thing has a 0 slope. At x is equal to 0, the slope here is flat. Also notice we're going to turn this off. So what do you notice about the y value of the derivative? Well, the derivative as x equals 0 has a y value of 0. What's that mean? It's the slope of the tangent slope. It's 0. And what else can we expect? Let's go over here at a is equal to negative 2 for a moment. Okay, there's a is equal to negative 2. I'm going to turn off this guy for a minute. I'm going to turn off the derivative for a minute, and I just want to read the slope. So let's take a look. 1, 2, 3, 4 over 1. It has a ratio of y, 4, and the x value, the run, is only 1. It's a negative slope because it goes downhill from left to right. So this slope is negative 4. All right. I'm going to turn this guy off for a minute and turn the derivative on. So let's take a look. At the x value of negative 2, what is the y value of the derivative slope? It's negative 4. All right. So here's the mind blower. I'm going to leave the tangent line off for a minute. Heck, I'm going to leave this point off for a minute. Oh, I just motivated it. All right, I'll leave it sit there. And I'll turn on just the graph and its derivative. So here we go. All the slopes here are negative. All the y values here are negative. All the slopes, tangent slopes of this parabola are positive. All the y values of the derivative are positive. As we get, and we talked about this before, I'm going to turn this back on for a minute. I'll turn this one off. As we get steeper and steeper and steeper and steeper, the tangent slope gets bigger, correct? As we go farther away from the y-axis, the tangent slope gets bigger. We'll look at g of x. I'll turn both of these off. As we get farther away from the y-axis, the tangent slope gets, in this case, absolute value. It gets steeper and steeper and steeper. It becomes -4, -6, and so on. All right, so there's the relationship between a graph and its tangent slope and the graph of its derivative. And we'll start there.